Okay, today's one of those fun days where I actually get to teach two classes the same thing. So this is actually going to be for my Algebra 1 students and for my Geometry students because it's relevant to what we're both working on right now. So my Algebra 1 students are working solving quadratics by factoring. We need to know about perfect square trinomials for that. And in fact, this is one of those skills that I told you guys in geometry last year that you should remember because it's going to come up again. And it is, believe it or not, for equations of circles. So for you guys in Algebra 1, please don't forget this because we're going to have to do this again next year. And, the less time we spend on it going over it, the better. But whatever, we'll take a few days to go over it. It's no big deal. So first of all, just a quick review of what a perfect square is. A perfect square is something like, oh, I don't know, 25 is a perfect square. And why? Because it is a product of the same number multiplied by itself twice, and that number happens to be a whole number, an integer. So what we would generally say is that something like this, square root of 1 is 1, so it's a perfect square. Right? In other words, if I take the square root of it, I get a nice normal answer. The square root of 2, not a perfect square. Okay, square root of 2 is a nice irrational number. That. Okay. So take it simple like that. Okay. Since this is an irrational number, we would not consider 2 a perfect square. So 2, not a perfect square. Okay, so generally speaking, as far as your numbers go, they're the numbers that kind of go diagonally across a multiplication table, okay? So I'll list them out here just as something, you guys should know. Again, what are they? Well, 1 times 1 is, well, 0 times 0, but that doesn't help us. 1 times 1, 2 times 2, 3 times 3, 4 times 4, 5 times 5, 6 times 6, 7 times 7, 8 times 8, 9 times 9, 10 times 10, right? And again, we can just keep going if we want to, 121, 144, 169. So again, if you know up to 144, learn a few more. Okay, learn a few more. It won't kill you. But again, like I said, we'll see these numbers as we go. Part of the reason we're going to have to know these numbers is we're going to have to identify things. So if you're not familiar with these numbers in general, break out a multiplication table. There's one posted on the algebra section of the website. So take a look at that, and we can and you can kind of go over them from there. Okay. If not, the square root button on a calculator is this little symbol right here. It might be a little bit easier to find in your calculator. So the square root of 16 is 4. Good. Okay. Now a little bit trickier part. We are going to focus about other things that are perfect squares. X squared is a perfect square. Okay? And the reason for that is that the square root of x squared is x, right? Remember, a square root says, hey, what number times itself makes this? Well, since x squared is x times x, what multiplied by itself makes x? Well, x does. X times itself, right? So pretty much what you're looking for is this, and I went over this with my algebra students the other day, so I don't want to spend too much time on it. Anytime you have an even exponent, well, that's x squared, because again, think about this. What makes x to the fourth? Well, x to the second times x to the second, right? That's x times x times x times x. X to the fourth. X to the fourth. So what times itself is that? So very simple. All you have to do is divide that exponent by 2. So if I said x to the sixth, that's x to the third. The square root of that is x to the third. If I said x to the 100th, x to the 50th. Okay? Good? We are going to be mainly focusing on x squares. So we probably won't get to too many where it's not an x squared. But you know, if we see it, we should be able to do it. It really shouldn't be that big a deal. Okay. So what does a perfect square trinomial mean? Well, what if I said this? I said x, well, let's use a different letter, n plus 7 squared. Well, that's a perfect square trinomial. First of all, can I take the square root of this? Well, again, since it's got a squared outside, the square root will undo this, okay? So for those of you guys in algebra, what are we concerned about? Well, now we have a way to get rid of that pesky square that we didn't have a way to get rid of before. For those of you guys who are in geometry, you should be starting to see that x minus h squared y minus k things start to show up here, right? That's where this is going, okay? So what does this look like? Well, again, I refresh you guys, you cannot distribute that too. It doesn't work that way. This is n plus 7 times n plus 7. So again, let's think about it. We're going to multiply our firsts, our outers, our inners, and our lasts. So what do we get? We get this pattern, n squared plus 14n plus 49, okay? And there's a pattern that we want to look for here, okay? There's a pattern we want to look for here, and that is this, okay? And there's a couple questions you got to ask yourself, so I'm going to rewrite this up here, n squared plus 14n plus 49, okay? First question, is that a perfect square? Yes. Is that a perfect square? Yes. Right? Square root of 49 is 7. Square root of n is n. Okay? And the last question you have to ask yourself, is this number here going to be essentially, you know, when I took the square root of this, it is n. When I took the square root of this, it is this. Is this 2 times those two numbers? Well, yeah, well, 2 times n times 7, that's 14n, okay? So essentially, if you want to check, we're going to take the square root of this number, we're going to take the square root of this number, multiply the results, and multiply by 2. We're multiplying by 2 because we had it added together twice here, okay? So I know it's a little bit confusing, but once you start to recognize the pattern, it really isn't that bad, and identifying this pattern is going to be important for us, okay? So let me put up another one here that I know works. So let's say I said x squared plus 16x plus 64. Okay. Well, again, is this a perfect square? Yeah. Right. Square root of x squared is x. Good. Is this a perfect square? Yes. The square root of 64 can be positive or negative 8. We'll talk about when we're going to get a negative in a second. Okay. True story. Is this one in the middle 2 times x times 8? Well, 2 times 8 is 16. Is it 16x? Yes, it is. So is this a perfect square? Yes. Okay. Now, for those of you guys who are in algebra, again, you could just factor this like anything else. Say, hey, well, A is 1, B is 16, and C is 64. What are my factors of 64 to add up to 8? It's x plus 8 and x plus 8. Okay? So the reason we're doing that is one of the methods we're going to use to solve quadratics is that sometimes we can make them a perfect square. We can make this a perfect square if we need to by kind of changing our equation. So it is pretty much the same thing. We are still just factoring it. Okay? Again, once you realize this, the pattern is just, well, take the first number, take the sign of this number, take the last number, and we're golden. So again, it's just a way to check more than anything. Okay. So I'll do maybe like one or two more, and I'll leave you guys to it. Okay. So what if I said x squared minus 4x plus 4? Okay. Is this perfect square? Yes. Is this perfect square? Yes. So again, what's the square root of x squared? X. What's the square root of 4? 2. Or negative 2. Remember, positive square, negative 2 times negative 2 also makes 4. Okay? So one of the things you have to watch out for this is this 2 times x times negative 2? Sure. Okay? So just watch that. Okay? Now, when you're rewriting this in factored form, again, let's take the first one. Let's take the sign of this number, negative, and let's take the last one, 2. Okay? So again, this is x minus 2 squared. I said x squared plus, let's find one, plus 10x plus 16. Okay. Let's use a different number. Let's use a number we haven't seen before. Plus 24. Okay. Now, is this a perfect square? Is this a perfect square? Yes. Is 24 a perfect square? No. You can stop right there. Not a perfect square. Okay. What if we said something a little bit different? What if I said 36? Okay. Is this a perfect square? Yes. Is this a perfect square? Well, again, the square root here and the square root here. Okay. Is this 2 times x times 6? No. So no, this is not a perfect square. Does that mean it's not factorable? No, we might still be able to factor it, but again, for what we're using it for a perfect square, this is not going to help us, okay? Okay. The next question is, hey, what number would make this a perfect square? Okay? And when a is equal to 1, it's a pretty straightforward process, okay? All I need to do is take 10 divided by 2 and square the result, okay? So our general form we're going to say b, right, 10 over 2 squared, okay? Well, 10 over 2 is 5, and 5 squared is 25. Now it is a perfect square. Okay. Well, what's 10 to, well, again, now that I know it's a perfect square, it's pretty straightforward. What's the square root of this number? X. What's the square root of this number? 5. Is this number positive or negative? Positive. Done. Okay. So what we really want to focus on, and this is for all you guys in algebra and in geometry, is when you're given a situation like this, okay? So go over one or two more, and then I'll set you guys kind of ready to go and do it, okay? So for number 4 up there, what do I want my c term to be? Well, again, it's x squared plus 2x plus c. All right, well, a is 1, so all we have to do is take b over 2 and square it. Well, what's 2 divided by 2 squared? 2 divided by 2 is 1, and 1 squared is 1. So I need my new c term to be 1. Okay, so again, what are my factors of 1 add up to 2? 1 and 1, right? Is this a perfect square? Yes. Is this a perfect square? Yes. What's the sign of this? It's done, okay? Now, I know in the first few we were checking, saying, is this a perfect square? Well, you made it a perfect square. You know it's a perfect square. So there's not much incentive to go ahead and check it. As long as you trust your math, it should be fine every time, okay? So for number 5, again, what are we going to do? If we want to make this a perfect square, again, b over 2 squared. So what's 14 over 2 squared? That's 7 squared, which is 49. So this should be x squared plus 14x plus 49. Again, perfect square, plus sign. All right. I am going to show you guys an occasion where this is not going to work very well. So say we took a look at number 8. X squared plus 5x plus c. This is not a nice situation. So a is equal to 1, but I need to take b over 2 squared. Well, that's 5 over 2 squared. So that's 2.5 squared. And again, there is an answer to this problem, but our C term is going to be 6.25. This is not going to be something that we're generally going to want to work with if we can avoid, because you're going to have a decimal. So anytime you have an odd number here in the middle, you're going to get a result that ends in 0.25 essentially. It's not that it's impossible, it's not that it can't help us, it's just that there's other methods to complete these problems that might be more efficient. For those of you guys in geometry, they never give you, an odd number. Okay, so don't worry about that. And in algebra, they're not, in year level algebra, they generally don't either. But they could, and we should be ready for it if we got it, okay? So really, no big deal. I don't have a whole lot of work for you guys. It's more of an introduction to what we're going to be doing next week. Give these 3 a try, okay? Again, this one's going to be an odd number. So divide by 2 and square it, divide by 2 and square it, okay? Thanks, guys.